In this video, we want to see how we can use what we call product rule to find the gradient function, which we call differentiating the function. So we have our question: differentiate the following functions and simplify to the lowest terms where possible. So we have the functions here, a up to d. Now when you look at these functions, you can see that they are a product of two functions. So if you are given a function, for instance, f, made up of two functions, u multiplied by v, product rule states that the gradient function of f is equal to v u prime plus u v prime. Okay, so what this means is, if you are trying to find the gradient function for f, you're going to first keep v constant, differentiate u, plus keep u constant, differentiate v. So the prime there means we are differentiating that particular function. So here when I say u prime, it means we have to differentiate u, and when I say v prime, we have to differentiate v. So this is what we call the product rule. Okay, and this is what you're going to use to differentiate these functions. So I'm going to start by solving the first one, which is a. So we have a, y is equal to x cos x. If you want to differentiate this one, you can see that we are multiplying this function multiplied by this function. So we are going to use what we call product rule. So the first thing, you let this be u, then you let this one be v. Okay, but you can make anyone to be u, the other one v. Okay, you name them alternatively. If you name this one v, the other one becomes u, and so on. So here we are going to write our product rule. Y prime is equal to v u prime plus u v prime. So we know our u is equal to x, then u prime will be, the derivative of this one is the power here multiplied by the coefficient, which is a 1 there. So 1 multiplied by 1, we get 1. Okay, we get 1. Then the power on x, 1 should reduce by 1. So what you're going to have is 1 x to the power 0. Now anything to the power 0, it is equal to 1. So it will be 1 multiplied by 1, which will be 1. Okay, so that is the differentiation of x. You multiply the power here with the coefficient, then reduce the power by 1. We come to v. Okay, we come to v. V is equal to cos x. Now v prime will be equal to, here, first you differentiate cos x, then you differentiate x again, but we've seen that the derivative of x is equal to 1, so we're just going to differentiate this one. Now if you're differentiating this one, there is the easiest way to remember when you're differentiating trig functions like cos or sine. So you draw up your circle like this one, you do it like this. On top here you put sine x, here you put negative sine x, here you put cos x, there you put negative cos x. So if you are differentiating, you go in the clockwise direction. So differentiation of sine x will give you cos x, but differentiation of cos x will give you minus sine x in that direction. So when you are differentiating, you go in the clockwise direction, but if you are integrating, you're going to go in the anti-clockwise direction. So the integration of negative sine x will be that, that will be that, and so on and so forth. So here, cos x, we want to find the derivative or differentiate cos x, we are going to come in the clockwise direction. So we are differentiating cos x, we are going to have minus sine x. So this will be minus sine x. The next thing that I need to do now is to replace in this particular formula. then I'll be done. So y prime is equal to, our v is cos x multiplied by u prime is 1 plus, what is our u? X multiplied by v prime is minus sine x. Now I can simplify. Y prime is equal to, this multiplied by that we get cos x, minus multiplied by this one we get minus, so it will be minus x sine x. And this will be the gradient function using what we call product rule, which is stated here. So again, we come to the second one, b. In b, again, we are multiplying this function and that function. Again, we are going to use what we call product rule. So we come to b. We have a function of x equal to e 2x multiplied by this. So we know the product rule is what you're going to use. You let this one be u and let this one be v. So you say u is equal to e 2x. Then u prime will be equal to, when you try to differentiate e, it doesn't change, so it will be e 2x. Now, when you differentiate e, you have to use chain rule again. You differentiate what is on top there. So e remains like e to the power 2x. Then we have to differentiate the power, which we should multiply. That is what is chain rule is all about. So we're going to say e to the power 2x. When we differentiate this one, we get this one multiplied by the derivative of what is on top, which will be the derivative of 2x is equal to 2. So when we simplify, this will be 2 like that. Okay, we come to v. V is equal to sine 4x. Then v prime is going to give us, again, we are going to use chain rule. Derivative of sine 4x, we get cos 4x. Now, when we get cos 4x, here we get cos 4x. Again, we have to differentiate this function multiplied by the derivative of this one. The derivative of this one, 4x, here it will be 1. 1 multiplied by 4, we get 4. Then x to the power 1 minus 1, which will be 0. 0, x to the power 0, it's 1. So 1 multiplied by 4, we get 4. So this will be cos 4x divided by 4. Now, I'm going to write my product rule. F prime is equal to v u prime plus u v prime. So what is our v? Our v is that one. So this will be equal to sine 4x, then multiplied by this one. U prime is 2e x, then plus, what is our u? Our u is this one, e 2x, multiplied by our v prime is this one, 4 cos 4x. Now at this point we are going to simplify. You can see that 2e to the power x is common. There we have 2, so I can factor it out. I'm going to have 2e 2x. Here I'll remain with this sine 4x plus, what will remain here is 2 because I factored out a 2. So we're going to have 2 cos 4x. And that will be our gradient function. Remember, we have to simplify to the lowest terms, or we have to simplify the answer. That's why you saw me simplifying here, because 2 e to the power 2x appears both sides, so we can factor it out. And this is what I did here. Okay, you are going to leave it there. Now I will leave this one for your practice. I'm going to do D. I'm going to do question D, because we've done, you know how to differentiate something like this, you know how to differentiate e to the power something, but since I've not done anything on in or natural log, I'm going to use this one. Then this one I'll leave it for your practice. So D, a function of t is equal to e to t in t plus 1. Again, you let this one be u and this one be v. So u prime will be equal to, when we try to differentiate, this one will be, remember the derivative of e remains the same, but again you have to differentiate the power, which you have to multiply here using what we call chain rule. So derivative of 2t with respect to t, we get 2, and this will be 2e to t. Then we come to v prime, which is the derivative of v, is equal to, when you are differentiating in of a function, it is 1 over the same function, then multiplied by the derivative of the function which is inside here. We use what we call chain rule, which was discussed in the previous video. So this one, t plus 1, when we differentiate, this one will be 0, then t, we are going to get 1. So here, this will end up to be 1 over t plus 1. Now, I'm going to write my chain rule. The derivative of a function of t is equal to v u prime plus u v prime. So what is our v? Our v is in t plus 1. Then the derivative of this one, u prime is this one, 2e plus u, what is our u? E to t. Then this prime, which is this one, 1 over t plus 1. Now I can simplify. You can see that e to the power e to the power 2t appears both sides, so I can factor this out. I'm going to have e to the power 2t. Here I will remain with 2, multiply this by this, I'll get 2 in t plus 1 plus 1 over t plus 1. And that would be our gradient function. So when you're given two functions that you are multiplying and you are taught to find the gradient function or to differentiate, you name the one to be u, the other one to be v, then you use what we call a product rule. Then remember, I've left this one for you to work out, but it's the same concept. You're going to say, let this be u, let that one be v, then you differentiate that one, you differentiate that one, then you use this particular formula. So for this and more videos, subscribe to my YouTube channel. Thank you.